before we get to nth roots. What is this? It's a square root. So if I asked you what the square root of, let's just say 25 is. 5, because plus or minus 5, because what you're doing is you're looking for a number that multiplies by itself how many times? Twice. So would it make sense to you if I told you that outside of the square root, there was a little imaginary 2 that sat right here? Yeah. Do you understand why? Yeah. Why might it be a 2? Square root, but why else might it be a 2? Twice, right? Okay, notice how this, I'm going to show you. I'm glad you asked. That's exactly right. All right, notice how this is written. Be very careful. This is not the same as this, okay? Make sure it kind of sits in there like it's sitting in a little chair on the radical right there, okay? Little teeny. Thank you. Thank you to my echoes here. They're so aggravating. All right, so again, Dozier just said, and he's exactly right, I could change this to any number that I wanted. In the chair, yes, in the chair. Here. What would that be? What number, this tells me what number times itself 3 times gives me 216. Is it plus or minus 6? It's just positive 6. Why? Why?
It'll be an I.
So what? Oh, would it be an I? Why?
No, it wouldn't, because it's not square rooted. You can multiply negative 6 3 times and get negative 6. The reason you I was square root is because you can't multiply by itself and get negative.
Look at you, Dozier. Good job, Dozier. Good job. He just explained I to you. You know? Because, okay, an odd number of times, if I do a negative times a negative times a negative, I get a negative. Well, we're saying that it's different if it was the square root of negative 25. That would give me the I, because I can't multiply it twice, you can't get a negative. But here you don't need the I, because you can multiply 3 times and get a negative. So, okay, odd roots. No I. They keep the sign that's under there.
I don't even want to pay that.
Yeah.
I
just go by the rule.
Education is not learning.
What does that give you? Negative 216. But let's say I had the square root of negative 25. You've got to multiply twice.
But if you can have negative 216 if you only have 4 negatives.
But the rule of the radical is it's got to be the exact same thing that many times. Like if it's a cubed root, it's got to be the exact same number 3 times. You can't do negative 6, positive 6, positive 6. Because the radical says exactly the same that many times. Like exactly the same. But
Right, you can't do it like that.
It's got.
It works though. It's got to be the same.
This has got to be exactly the same 3 different times. Like this has to be either 5 times 5 or negative 5 times negative 5.
Yeah, but that one's negative 6.
Correct. Thank you. No, we haven't done. Okay. Any number. I can have any number for this root that I choose. Any number. Any number. How many numbers can I have? 2. Any number. What does this mean?
4.
4 numbers, right? It times itself 1, 2, 3, 4, and all of those numbers have to be exactly the same. Okay. This is an even root. Even roots get plus or minuses.
They all get plus or minuses.
No, they
Odds do not. Odd roots keep the sign that's there. Okay, so here, what number times itself 4 times gives you 2401? Did y'all just know that? Now, I'm going to show you how to use your calculator to help you, yes. Take out your calculator. Y'all clearly got plenty of rest this weekend because you are off the chain today. I wish I had a Halloween there. I'm pretty tired.
Actually, I didn't want to watch you football.
Like that 1978 Halloween.
You got scared of Michael Myers. Those movies ain't
I'm
even
sure
scary.
that's the president.
Those are slashers. Those aren't even like. You watch those for like kills. You don't watch the Conjuring. Watch the Conjuring. Watch the Conjuring.
No.
That movie is scary.
Why do y'all watch scary stuff? It doesn't make sense. Plus or minus.
It's 1 over 3. It's 1/3. It's negative 1/3.
Negative 1/3. Odd roots keep the sign. Even roots, remember. Somebody help me. Yeah.
Well, I thought you would have to do the
No, you
times
can.
27.
For even roots, but odd roots you can. All right, look. Odd roots keep the sign. Even roots plus or minus on positives. Somebody help me say this a different way for the people that don't understand it.
Odds roots can have negatives because of 3 times. There's your understanding. There are odds and negatives. Negatives cancel out to a positive. Brings back to negative.
Okay. Wyatt, what is that one?
2.
Close.
It's odd. It's odd.
Oh, negative.
Negative 2. There you go.
What 27 times 27?
Why are you doing 27 times 27? I'm going to show you on your calculator.
There's the bottom, right? So you have to put the, what you call the bottom 2, right? Times it times 27.
No, because you don't have to do that because the cube root of 1 is 1, the cube root of 27 is 3. It goes away on its own.
But if it was a squared root.
If it was a squared root and wasn't a perfect square, you are exactly right. You would rationalize the denominator. Okay, Emma asked, how do you know some of these numbers get larger than what we would like if we don't know them off the top of your head? So I ask you to take your calculator out. Your calculator. If you hit the button that says math, under the green alphabet, okay. All right. You see option number 5 has X root. Option number 4 is third root. Option number 5 is X root. So here's how you use it. Exit out of this. Just hit second mode to quit. Come back to your home screen or just keep hitting clear until you're back in your home screen. Let's say I want to do the fifth root of negative 32,768. What I'm going to do is I'm going to hit the 5 button first. Hit 5 and then hit math 5. And then hit negative 32768. Let me hook my camera. I think I showed you, Adriana, using exponents. Yeah. I don't want to do that quite yet because we're going to get to that soon. Yeah. Hold on a second. There we go. Okay, so I went, if you're still having trouble, I hit 5 for the fifth root, and then in the math option, I chose number 5 here, and then type in that, what was it, negative what? Not everybody at once. Thank you.
What's the number again? Let me see if I did it right. What's that number?
Negative 32,000. How did you guys change from rain to green?
Jalen Hurts squats 600.
There's no way Jalen Hurts
I
squats.
swear he does. There's a video. There's literally a video. Now, what about Aaron Rodgers' fake?
What is it like? Who's the one? Wait, what?
Is this right? Look.
Yes, it's your phone.
Who said Jalen Hurts couldn't
It
squat?
looks like all of that sound where it's like, I don't know, before, after we were talking about here. Right.
He's an old man. Who? Aaron Rodgers squats.
All right, guys, y'all stay with me, stay with me, stay with me. Okay. Just to recap, I'm going to run through these quickly. I want you to tell me how many solutions. How would I know that? How many answers should you get here?
3.
One answer this way, right? But if this was the square root, I would get 2 answers because I need the plus or minus, right? Okay, so odd's going to give you 1 answer, evens are going to give you 2. Odd roots. Okay, so we've already said about the signs. Odd roots keep the sign. Even roots must be positive. Okay. And then here I get one answer or one solution or reduces to one. Here I get two because I have to do the plus or minus. This is when I get imaginary solutions. This is when I never get imaginary solutions. All right. This is the easy part. This is the background. All right, but let's talk about how we simplify because here's when it's going to get more difficult. Yeah. All right. Simplifying. Guys, we can get through this a lot faster if y'all work with me. I'm ready. You're waiting on me because somebody said, hold up and let me copy this. I was fixing to say that, like, I'm spitting. I'm getting so excited. Okay. Simplifying radicals. Ready? Let's start. Did I scare you? I'm sorry. Don't ever get scared. I get excited. I'm fixing to show you. We've done it with square roots. We've done it so many times with square roots. Remind me how we simplify a radical.
You just find your factor of 3.
Okay, so biggest perfect square that I can divide 117 by. Nope, it's not. 3 goes into 117. 9. 9 works. 9 and what? I like how y'all just keep guessing until I tell you, yeah, that's right. Okay, so that means this simplifies 3 times the square root of 13. Is everybody okay there? All right. But what if I make it well, actually, before I do that, just as a recap, simplifying radicals. What if there was something outside that I was already multiplying by?
Times that 3 to the...
That's exactly right. So what's the perfect square I can divide 320 by?
I don't know. 12. 4.
You can do more than 4.
Do 4 and 80.
So y'all keep hollering numbers that are not perfect squares.
4 and 80. 4 and 80, then you just have to factor.
There you go, 64. I found it.
64 times 5.
Why? You were so angry when you whatever. Okay, square root of
32 square root of 5.
There you go. Because the square, what's wrong? I'm sorry.
Same answer.
64 times 5 is 320. This is another example. Yeah. Which is, of course, 32 square root of 5. And I'm going to throw the plus or minus because it is a square root, right? I did. I realized it after I... All right. This is old, right? That's what we've done. Now we're going to do it with other roots, okay? So what if I had... This time, as I simplify, I'm looking for perfect cubes, right? So what are perfect cubes? Well, 2 to the third is 8.
8 and 6. No, you can say 6 is going to stay in square root. Well, it's 2.
So the biggest one I could divide it by would be 8. 8 and what?
So you get 4 and 6. 4 cubed root of 6.
Okay.
4 cubed root of 6.
I look at this. This is the third, right? So I'm looking at powers of 3. And just like with square roots, I want to choose the biggest one that I can divide 48 by. That was 8. 8 times 6 is 48, right? So now what's the third root of 8? So I got 2 times 2 times the cube root of 6, which is 4 times the cube root of 6. Do I need a plus or minus here? Why? It's an odd. All right, I'm going to give you one to do. Ready? Oh, be more excited than that. You do or don't?
Wait, what's 27? Yes, it is.
Don't be ugly.
I said 27.
Yeah.
Why are you talking about 64?
Because that's what Dozier was saying.
What?
You said 4. You said 4 squared.
So it's going to be 9 cubed root of 4.
Not
Oh,
nine.
wait, no, negative 9 square root cubed root of 4.
How'd I get what, Sullivan? Did you ask something? I said how'd you know? It doesn't matter because what I'm going to do here is I'm going to take it out anyway and put it in the front. So negative 9 times the fourth root. Yeah.
That's not a 4. That's a 3.
Oh, sorry. Y'all stressing me out a little bit.
Little mistake.
Hey,
I do love y'all. Great day. What?
Little things make big things.
Okay. Let me give you one more a little bit harder. They're off the chain, aren't they? Like, y'all are like. Yes. Simplify. This one's for you, Wyatt.
Or.
No. It's the fourth root.
Y'all got that.
All right, so look. Yes, use your calculator, but it's not going to be an exact one. So, Emma, what I'm going to do is I'm going to come over to the side probably and think, okay, not to simplify now. So I'm going to start dividing by power 2 to the fourth, 2, 4, 8, 16. Can I divide by 16? 3 to the fourth is 81.
Oh, I got one. Hey, it's 48,
Oh, I know what it is. It's 20 to the square root of whatever. 4 cubed root of 2. That's what it is. Gotcha.
16's got 4.
It's 6 what? 1296. 6. She listed out the.
These are powers of 4. Yes, they are.
Those all are 2 times 2 times 2 times 2. Why?
I'm very impressed with
Well,
those
this is
this
stuff I
morning.
actually know.
All right. So this is fourth root, 1296 times the fourth root of 2. This is 6, yes. So I have 5 times 6 times the fourth root of 2, which is 30 times the fourth root of 2. I do need the plus or minus because it is an even root. Okay, let me crank it up a notch.
I don't think it's great. I mean, we're at like the limit I can do in my head.
How to what? You just start dividing 2592 by these numbers until you find one that works. So if I wanted the fourth root of 1296, go 4, math 5, and then 1296. She does. I showed her. I showed her before because I couldn't figure out how to do it on here.
Or where are the highlights? Or where are the highlights?
But you know that the reason too, you can't use that calculator on SAT and ACT. And that's why, is because it does things like that. The 89s, you can't use them on like SAT and ACT and all. They're too powerful.
Wait, which is?
Hers is, she's asked a different question.
What's the question?
Could she?
No, I'm talking about.
Oh, okay, here we go. I know. Tell me how you really feel. The 32 is easy. You should be able to get that no problem. It's the variables that are gonna. Yes. Okay, so let's think about this. All right. We know 16 and 2. Let's take care of that first. Okay, let's do 4 root 2x4y9. Why? Four x2 y3.
Yeah.
So you're telling me that
3 times 3 is 9? Yes.
is that what you're telling me?
Oh no, you add them together. So I'm right, it's 4.5.
Which means what?
Because you add them together, so you get 9, 4.5.
What goes on the outside and what goes on the inside?
Or you can do 5.
You say it's 4. You said why 4? Okay, so I hear. What goes here this way? It's just 1. You're right. If I'm here, and I think, Slade, this is what you were saying, and you said put a 5 here. This one's not wrong, but it's not completely simplified. This one is completely simplified. So what did we do? What does it mean to... Look, I could rewrite this, the square root. Let's just look at the square root of y to the 9th, because that's the one we're struggling with, right? I could write that as y to the 4th times y to the 4th times y to the 1st. Do you agree or disagree? Because you add them all together, right? Well, since these are exactly the same, okay, now, here's a little trick that will help you. This is not very mathematical, but I find it's the easiest way to show you how to do it. divide the exponent by the root that's outside. Okay? This case, what was it? 2. Okay? So if I do 9 divided by 2, I get, and here's where I'm going to contradict myself just a little bit because I told you never to write a remainder out. But 9 divided by 2 would be 4, but what's my remainder here? 1. This is the exponent outside. This is the exponent inside. Okay? That's the way variables are always going to work with roots. It will work every time. Look at what I had with the x to the 4th, right? We had the square root of x to the 4th. Well, what is 4 divided by 2? 2, and there was no remainder, so there's nothing left under the radical. Does that make sense? How about if I had the 5th root of x to the 27? You'd get 27 divided by 5 is 5, with a remainder of what? 2. I don't know what that means. Okay, it's just a little trick, so you don't have to sit here and go, I don't know. It'll help you with that. Okay, so let's do an example. Okay. No, with all the variables and everything. You try this one. Cube root 56 R8S4. It's a cube root, yeah. Don't say it out loud. Yeah, don't say it out loud. Don't say it out loud. Say again? Because that's not real life. Okay. All right. 8 and 7. That gives me a 2 outside and a 7 inside, right? Now let's look at the variables. 3 goes into 8 how many times? 2 times. So I have 2 outside, and how many are left? 3 goes into 4 1 time, and how many are left? 1. I know, you don't have to write that one. I did. Thank you, Solomon. So this is 2r squared s times the cubed root of 7r squared s. One more, and I'll stop. 2 more. Oh my goodness. Yep. Do I need a plus or minus on this one? Why? It's odd root. It's an odd root, bless you. It's cube root, right. If that root is odd, you keep the sign. If that root is even, you need the plus or minus. Do an easy one.
Got a wire for
Why? You should be done. Close. How many times is 4 going to 8? Nothing left over. No more radical. Nope. If you can do the little trick with division, you won't have any trouble simplifying radicals. We'll solve with them soon, but not yet. I'm not gonna lie, my gut said I should do 2 lessons today because I wasn't gonna be here tomorrow. We really should have. We're still gonna do 2 lessons. It's 19 and you have 40 minutes. Did y'all get this one?
Hold up.
Okay. Okay. I forgot to count one. While I appreciate your sacrifice, Dozier, I have plenty. Thank you. Four through 625. 5 and 125.
But it has to
Yeah,
be 5.
okay.
But it has to be
But-
root of the 4. Plus or minus
A root of the 4. This is a perfect fourth, yes? 5, 4th root, C23, D11. 4 goes into 23 how many times? 5, and how many are left? 3. 4 goes into 11, and how many are left?